Hi everyone, thanks for joining us for today's event, The Missing Link in Software Test Automation, Intro to Automated Visual Testing. My name is Adi and I'm the event's moderator. Today's speaker is Adam Karmi. Adam is the co-founder and CTO of Applitools. Prior to Applitools, Adam held management research and development positions at SafeEnd, IBM, and Intel. In addition, he regularly talks about software testing at conferences around the world, such as Selenium Conference, GTAC, and Eurostar, just to name a few. And he also organizes the Israeli Selenium meetup group. Before Adam kicks off, just a bit of housekeeping. Questions. Feel free to ask them during the webinar. You can do that in the question section in the GoToWebinar control panel on your right. We will try to answer as many questions as possible at the Q&A session at the end. The questions that we won't get to will be answered via email after the webinar. On demand. Yes, this webinar is being recorded and a link to the recording and Adam's slide deck will be emailed to you tomorrow. Also important to note that Adam will be showing live code examples. So for optimal viewing experience, I recommend you close any unnecessary apps running in the background and view this in full screen mode. Also, if you encounter any technical issues, please send me a message in the chat room, also in the GoToWebinar control panel, or in the questions panel, and I will try to take care of it as soon as possible. So Adam, I think that we have mostly everyone here, so I think you can start. Stage is yours.
Thank you, Adi. I hope you can hear me well. Hi everyone, and thank you for joining the webinar. In this session, I'll give a very thorough introduction to automated visual testing. As part of my job, I get to meet a lot of developers and testers, and I'm always curious to learn how they do visual testing. Now, there are still many teams that don't know what visual testing is, and many that think that I'm asking them about a tool called Sikuli. So the main thing I hope you take away from today's session is that you understand what visual testing is and that you can and should automate your visual test. But if in addition you can also remember that visual testing is not all about Sikuli and tell that to everyone you know, that would be a huge bonus for me. So we have a lot to cover. We'll start by explaining what visual testing is and why it should be automated. Then we'll take a deep dive and review some of the tools that are available and how they work under the hood. And we'll conclude the session by describing how automated visual testing fits in the modern development and testing lifecycle. And of course, there'll be time at the end to answer any questions that you may have. So what is visual testing? Visual testing is a quality assurance activity that is aimed to verify that the UI appears correctly to the end user. Now this goes beyond the traditional functional testing that you used to do with tools like Selenium and UFT or Coded UI, where you basically test the functionality of the application through the UI. What we're focusing on here is making sure that the UI itself appears correctly to the end user, that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. Now, naturally, this type of testing has become increasingly difficult to perform manually in recent years, mainly due to the explosion in the amount of devices, operating systems, screen resolutions, and devices that applications are expected to run on today. Here's an example of a visual bug that we found in the Twitter application. You can see that this one was caused by the narrow form factor of the device. There's not enough room for the notification text, and because of that, it overflowed on top of the notifications below it. Here you can see a visual bug in Financial Times where the article title overflowed on top of the article body. And this is how the Amazon website looked like on Amazon Prime Day last year. So I'm sure that you've all seen this type of bugs before and you understand their severity, they're embarrassing, they can hurt the company brand, but in many situations they can completely cripple the functionality of an application or a website and end up costing a lot of money. So why should we automate visual testing? There are many reasons for that, but the most important one is that the test metrics has just become too big to cover manually. Think of all the different web browsers, devices, operating system, and screen resolutions that are out there. We all know that if a website looks good on IE, doesn't mean that it would look good on Chrome and vice versa. We all know that if an application looks good on a widescreen, doesn't mean that it would look good on a smartphone. So basically, we have to test our application on all these different execution environments, which takes a lot of time and effort to do manually. If our application is responsive, then we have to test all the different layout modes and the layout transition points across these environments. If it is localized to different languages, then each language has its own fonts and resources and images and content. So all of these, of course, affect the UI and can have their own unique set of visual bugs that we have to test against. And of course, even if we don't change a line of code in our application or website, we still depend on third-party upgrades. And the trivial example for websites is the browser itself. It updates every 2 weeks or so, and whenever that happens, it can introduce incompatibilities with our site that can manifest themselves as visual bugs. So basically, we have to test all the time. We have to test everything. We have to test it on all those different execution environments, and it's simply impossible to do manually. When it comes to mobile applications, quality becomes even more critical. The main difference is that it's it's impossible to roll back changes. You cannot push daily to the App Store, and even if you find a way to work around that, those updates will take battery and data and upset your customers. And of course, users can opt out of updates, so they can just keep your bugs forever and give a poor rating to your apps. In general, there's a much higher quality bar when it comes to mobile applications, simply because mobile users are much less tolerant to UI and UX bugs. And of course, what complicates things is the fact that release cycles keep getting shorter and shorter. Companies that are practicing continuous deployment, which is the current hype, are releasing code to production several times a day, and with such short release cycles, there's hardly any time to do any type of manual testing, let alone making sure that the UI renders correctly across all these this multitude of execution environments. So let's continue and look at the different tools and how they operate under the hood. Now, there are over 30 different open source and commercial visual test automation tools out there today, but they all share the same basic workflow that consists of 4 steps. In the first step, you drive the application on the test and take screenshots. In the second step, the tool compares those screenshots with baseline images, which define the expected appearance of the application at each point of the test. Now, in the majority of cases, these baseline images are simply screenshots that were sent to validation on previous test runs and were found to be valid. In the third step, the tool generates a report that consists of all the screenshots, the baseline images, and any differences that were found. And in the last step, a tester or a developer or any other human being looks at the report and decides for each difference found, if there were any, whether it is a bug, in which case he rejects the new screenshots and opens a bug, or if the change is valid, he simply approves the new screenshots, so they would become baseline images for subsequent test runs. Now that we understand how visual test automation tools work, let's run our first visual test using Applitools eyes. Now, for the purpose of this demo, we'll write a very simple visual test for this Hello World website. Basically, we'll open up a Chrome browser and visit this URL, and then we'll validate this page, and we'll click the button, and we'll see this thumbs up image telling us that we successfully clicked the button, and we'll validate this page as well. Now, we'll start with just the basic code that does doesn't do any type of visual testing. It just uses the WebDriver, in this case in C#, to just drive the application on the test. So let's go over this very simple program. It starts by opening up a Chrome browser. Then it navigates it with using the WebDriver to the URL that has the Hello World page. And then it finds the button by its tag and clicks it, which will actually move us to the state where the thumbs up image is shown. Now at the end we close the browser. So it's a very, very simple procedure to visit a URL and click a button. Now let's add visual validation using the Applitools Eyes C# SDK. We only added a few lines of code. Let's see what we did. So we start by, after we create a driver, we create an instance of the Eyes class, which is the main class of the Applitools Eyes SDK. We also indicate the URL of the server that we're running against. In this case, it's the Applitools demo server. We then proceed to set the API key that identifies our account. In my case, it's hidden behind the environment variable Applitools API key. At the beginning of the test, we call eyes open to indicate to the eyes server that we are starting a new test. We pass in the WebDriver. We pass in a name for the application. It could be any string you want. And a name for the test. Again, any string would do. The fourth parameter is actually a viewport size that the SDK will set at the beginning of the test. It will resize the size of the browser window, so the size of the browser viewport will be 800 by 600 pixels. This is important in order to make sure that you get consistent screenshots when we're running the test on different screens. And also, it's important because by setting the viewport size, you actually force the application or website in this case to assume the required layout, and this is important when you're testing a responsive website and want to check its different layouts. Now, with this we are done with the initialization part. Now we can actually add verification points. So after we navigate to the first page, to the Hello World page, we simply call eyes check window. This will capture a full page screenshot of the current page, even the parts that are below the fold that are not visible through the viewport, and send it for validation against the baseline. It will actually detect any difference whatsoever in the entire page, and by writing this single line of code, we just saved ourselves the need to write hundreds or even thousands of equivalent assertions, preparing test data, etc., and of course maintaining those as the application evolves. Then after we click the button and change the UI state, we call eyes check window again, which will validate the second page of the application. So with these two lines of code, we have 100% coverage, test coverage for everything that is visual in our application. At the end of the test, we call eyes close. And at this point, if any differences were detected, an exception will be thrown that will fail the test, and in the message of the exception will be a URL that points to the report in the Applitools Eyes dashboard. Let's run the test and see what we get. We can see the browser starting, resizing to the required viewport size, clicking the button, and we're done. No exception was thrown. And if we go to the Applitools Eyes dashboard, we can see that we have here a new entry that is green, indicating that no differences were found. The test has passed. We can see the name of the test, my first Selenium C# test. We can see the two checkpoints, both of them green, indicating that there were no difference compared to the baseline. We can drill down and see that indeed we have two checkpoints here on the timeline, and each one of them has a baseline image on the left-hand side and a current image that is being validated on the right-hand side. Now, what we are going to do next is simulate a difference. And the way that we're going to do that is that, as the page here tells us, if you add diff1 as a query parameter, then every time you refresh the page, you'll have a random number here. So you can see I'm refreshing it and it's different. So let's simulate this difference in our application by actually going to our test code and adding diff1 to the URL. Let's rerun the test and see what we get. The browser is starting again, resizing, validating, clicking the button, validating, and you can see that in this case we do have an exception. It's a test failed exception, and we also have a URL to the test report. Now if we go back to our dashboard, you can see that we have a new red entry. You can see that we have our thumbprints of the screenshots taken with pink indication of errors. We have the radar button over here that we can use to highlight, and as expected you can see that it's where the number is. And we can also zoom in on the difference and see if we toggle between the baseline and current image that indeed it is different. Again, the radar button will help us find all these differences easily. So as you can see, any difference between the screenshots that we're validating and the baseline would get picked up. Now, as far as the maintenance goes, all we need to do is approve the change or reject it. We can also approve all occurrences of the change across all the checkpoints of the test, and it's very easy to maintain just by giving that indication. Okay, so the next thing we're going to do is that we're going to take a closer look at each step of the workflow and see how the different tools that are out there implement it. And the first step that we'll start with is comparing screenshots with baseline images, simply because this is the most important and most technologically complicated step to get right. Now, if you allow me to quote Boromir, then one does not simply do bitmap comparison, or in this case, pixel-to-pixel comparison. The reason is that if you just compare pixel to pixel, you'll get a lot of false positives and you'll end up throwing the tool away. False positive in the case of a visual test is a situation where the tool tells you that there's a difference between the images, but it is impossible for you as a human to see it, or it's so minute that you don't care about it. Now, there are many reasons for these false positives to occur, and let's take a look at two of the common ones. The first is an image processing effect that is called anti-aliasing. You probably heard about it. Let's see what it's all about. You can see that we have a navigation bar here at the bottom, and we have the playlist tab that is now selected. And you can see the content of the playlist tab shown here magnified. Now, although the text on the tab here appears to be white, and if we would look at the DOM of this web page, you will probably see that the color of the text is white. However, if we look at the magnified pixels, we can see that many pixels are not white at all. We have here different shades of blue, right? The reason these pixels are actually anti-aliasing pixels that are added by the graphics card, who is actually drawing those letters for us, for the browser. The reason these pixels are drawn is because they cause an illusion that makes us as humans see the font to be smoother, and we don't see those stairways and jagged edges that happen whenever you draw a diagonal line on the screen, just because these are pixels. Now, anti-aliasing is a great thing. The problem that it causes with visual testing is that if you are running your test on more than one machine, which makes sense if you have more than one tester in your team, or if you're running your test in a lab, then you're likely to have different hardware there, different graphics card. Perhaps the computer is connected to a screen with different capabilities. Perhaps the version of the device driver is different, or some other zoom level or other desktop property is different on that machine. And this can substantially create different pixels on the screen. Different graphics cards have different implementation for anti-aliasing, and they would produce different pixels. So for example, this is how a different computer would draw exactly the same page. So if I toggle between the two, you can see how the anti-aliasing pixels can be different. At one place they are just different shades of blue, on the other they are in pink, but still in the original navigation bar you can't see the difference because it's invisible to the human eye. Now if you would just use pixel to pixel comparison, the tool would fail and the test would fail and would tell you that there are differences, but you won't be able to see them with your bare eyes. So that would be a false positive. And what you need to do is use image comparison algorithm that is far, far more sophisticated and smart to be able to detect that these are differences that a human being cannot see. Another common example that is a source of false positives has to do with image scaling. So whenever you have an image on your website or in your mobile application, and the source for that image is an image of a different size, then the graphics cards need to scale it to fit the target size. It needs to make it bigger or smaller. Now then again, different graphics card or different settings would produce different pixels. Although we cannot see it, they are different. So in this example, we have this car image, and here we have this pink rectangle that is being magnified over here. If I toggle between two renderings of the same image on different computers, you can see how different the pixels over here are. Now, of course, this is completely invisible to the naked eye, but still, a lot of pixels are different, and pixel-to-pixel comparison will highlight that as a difference. So then again, you need a sophisticated algorithm to be able to ignore these changes and not fail your test for these cases. Now, these are just two examples. There are plenty of others. You have 1 pixel offsets in element positioning all the time, arbitrarily happening. You need to deal with dynamic content like dates and usernames and ads. You have moving elements. You need some time to be able to compare images of different sizes. And of course, the algorithm has to be super fast. Otherwise, your test will take forever to run. And of course, there are those that no matter what they do, they get mismatches. But seriously, visual test automation tools have come a very long way in recent years in terms of dealing with these challenges, these image comparison challenges. But before you start your way with visual testing, and when you're choosing your tool, make sure that you're choosing a tool that will not produce false positives for your application. The reason is that if you do go with a tool that produces false positives for you, you will never be able to scale up your test, and it will always be a source of burden and maintenance overhead, and you won't be able to really succeed with visual testing. Let's review some of the image comparison engines that are out there that upon which all the different tools are based. The first one and oldest one is MagiCK. It's a very popular command line tool for doing all sorts of bitmap processing. You can change the format of a bitmap. You can scale images, rotate them, change their colors, all kinds of nice stuff and cool stuff. You can also compare two images using this tool. It also has a fuzzing feature that can be used to eliminate some color and pixel differences, and it can handle to some extent some of the causes for differences that we've just discussed about previously. Now you can see here at the bottom how you can operate it. You call compare from the command line, passing in the first and second images. And you can also pass in a third image that will contain any diffs that are found. So MagiCK will output the number of different pixels found, and it will draw in the diff image the second image with all the different pixels highlighted in pink. So you can visually see what is different. Now there are many tools, visual test automation tools that are based on MagiCK. And all of them rely on an error ratio to determine if the images match. The error ratio is basically computed by dividing the number of different pixels by the area of the images compared. This provides you with an error percentage, and the tools that are based on MagiCK basically allow you to, in your test, to determine a threshold, let's say 1%, 0.1%, any threshold that you choose. And if the error ratio is below the threshold, then the test will pass. If it's above it, the tool will consider the test to fail. Next, we have the three popular JavaScript engines, Resemble.js, Blink.diff, and LookSame. The first one is Resemble.js. It's a very popular and good image comparison engine. It also operates pixel by pixel similarly to ImageMagick and relies on an error ratio. But beyond what ImageMagick can do, it also has very good treatment of detecting and eliminating and ignoring anti-aliasing pixels. Blink.diff is similar. It also has good ability to look at color differences similarly to how a human does. So it does a better job at ignoring, eliminating false positives that has to do with color differences. And LookSame has similar capabilities, and it also ignores differences that look like a caret or a cursor, so that if you have a text box with a blinking caret there, you won't have failures because of having the caret shown or missing. And this leads us to Applitools Eyes, our own Applitools Eyes, our image comparison engine, which is a commercial engine that was built specifically to solve the visual test automation problem. It perfectly handles all forms of, all causes of false positives, including anti-aliasing, pixel offsets, color similarities, image scaling, and many others. It can easily handle dynamic and moving content, compare images of different sizes. What's special about it is that it actually emulates the human vision. It doesn't require you to specify any error ratio or thresholds at all. The only criteria is if a human being can see the difference or not. So for example, if you have a huge web page with tens of millions of pixels and a plus symbol changes to a minus or a comma changes to a period, this could be just 4 pixel difference. The tool would actually highlight that as different because it's visible. On the other hand, if for some reason, and that happens a lot, you have a table in your web page and one of the columns would get to be 1 pixel wider, and that would shift the rest of the page 1 pixel to the side, and you'll get a 70% pixel-wise difference. Still, the tool is smart enough to ignore that entire difference because it can understand that a human being cannot see it, although that pixel to pixel, it is substantial. Now, another thing that is very special and unique about it, that it can actually analyze and understand the structure of the images and compare those images of your applications by their layout or their structure, and I'll show you how that looks like. Now, layout matching or structural matching is useful in several ways. The first is to actually be able to perform cross-device and cross-browser tests. That is, to use a baseline from one execution environment to validate the structure or layout of another. So in this case, we have a website here. You can see that the baseline image was taken on Chrome, and the current image was taken on IE. Now, I think you'll probably agree with me that those websites look exactly the same if you look at them like this. But if we toggle between the two, you can see how differently the two browsers render the same page. You can see that the text is slightly different, the font is slightly different, the size, the position, the paragraph here wraps differently, the scroll bar is different. There are plenty of differences. However, the two images are consistent in the structure, and because of that, layout matching will not highlight these as different. If we click the radar button over here, you can see that we do have a change here at the bottom, and if we zoom into it, you can see that we did find a missing element in IE over here. And so this is a very powerful way to detect structural and layout defects across environments using structural matching. The next example I want to show you has to do with mobile devices. In this case, we have a baseline taken on a Google Nexus 4. This is the GitHub homepage. You can see that it's a full page screenshot, not just what's visible in the viewport. And the baseline is a Google Nexus 4 and the current image on a Google Nexus 5. Now, if I toggle between the two, you can see the different form factor. The devices have a different width. If we zoom in, then as you would expect, there's more horizontal space, the text would wrap differently, the image can be bigger, but still structurally the page remains consistent, and because of that none of this is highlighted as different. If we zoom at the top, we can see that we did capture a layout issue where the logo moved from its expected position. So then again, another example of doing cross-device testing and capturing layout differences. The last example I want to show you is the ability to actually validate extremely dynamic pages. So in this case, we have the Yahoo website homepage. You can see this is a very dynamic portal, and here there's a 24-hour difference between the baseline and the current image. You can see how the articles are different, the images are different, and naturally there's a lot of differences here, but because the layout is consistent between those two images, nothing is highlighted. Of course, if I change this to strict, then all the dynamic parts would be highlighted in pink and the static parts won't. But if I change this to exact pixel by pixel matching, you can see that everything here is different. It's just that the things that strict was smart enough to ignore those changes that we cannot see as human beings. Okay, so now that we understand the technology behind screenshot comparison and what is possible to achieve these days, let's move on to the first step, which and look at how the different tools drive the application on the test and take screenshots. So although all the different tools share the same workflow, we can still roughly divide them into two categories. The first category is that of the quick feedback tools, and the tools in this category are mainly useful for front-end developers who want to get fast feedback on code changes that they just did, possibly before committing the code to source control. Of course, these guys don't have a test lab at their disposal. They just work on their local desktop, their development machine, so they don't want the test to run in the background. They don't want to have like browser windows popping up and interfering with their work. And the common setup for these tools is to render screenshots with a headless browser such as Phantom.js or Slimer.js. And mostly these tools are driven by a configuration file that has a list of URLs to visit, get screenshots, and validate. Now, this is very useful for the purpose of getting quick feedback. However, there are many disadvantages to this approach. First of all is very partial coverage. So Phantom.js and Slimer.js are headless browsers that rely on the Gecko and WebKit layout engines, which cover Firefox and Safari. Then this leaves out Chrome and IE, which are kind of important browsers. In addition, because these tools rely on configuration files, simple configuration files to drive the tests, it's difficult to get to all kinds of interesting UI states that require filling out forms or clicking buttons or hovering over elements, so you can't really test everything. The other disadvantage is that those tools, Phantom.js and Slimer.js, are not updated every time there's a new browser version, and because of that they have old layout engine versions. So you might end up in a situation where your tests with Phantom.js are passing because you're relying on an old version of the layout of the Gecko layout engine, where in the real Firefox browser you have a bug. So, but these tools are really useful for getting quick feedback. The other type of tools, which we call the visual coverage tools, actually are aimed to verify that the application or website looks right in all real execution environments, and and they allow you to test as many UI states as possible and run the test in parallel and scale them up. And the setup here would usually be based on a WebDriver and a Selenium grid or some other kind of solution that allows you to scale up your test, run on a variety of real operating systems and devices. The tests themselves would mostly be driven by code using a WebDriver or some kind of DSL on top of it that basically allows you to emulate any user action and get to any state of your application. The downside of this approach is that it does require you to invest in test infrastructure and implement and maintain test code, but anyway, for teams, but for test professionals, you already have this lab in place. You're already maintaining functional tests, so adding visual validation is very easy and doesn't add any burden or disadvantage. Now here you can see a list, a very partial list of tools that are available. Just a few things to highlight about this list is, first of all, you can see that there are plenty of tools from both categories, both the coding and both the configuration type of tools. You can see that for almost every prominent programming language, there is a matching visual test automation tool that can be used to add to implement visual tests for a large variety of test automation frameworks. And another important thing is that the vast majority of these tools will only work for web applications, for browsers. The only exception is Facebook Snapshot Test Case that will work for iOS applications, and Applitools Eyes that can test any native mobile application using either IPUM, XCUI, or Espresso. And this brings us to the third step of reporting differences. And many of the open source tools actually report the differences as images on the file system. This means that the baseline images are basically filed in a certain folder with certain patterns of file names. When you run the test, you get the current images as files in a different folder or with a different prefix or suffix in the file name. And you'll get a diff image as shown here with the different pixels highlighted in pink, just like I explained when I talked about Image Magic. Other tools go a step further and show you like a nice report with statistics about test runs, how many screenshots were matched, how many mismatches, with the ability to drill down and see thumbprints and look at the differences up close. Some other tools like Applitools Eyes can actually embed the dashboard inside the CI system. So if you have a Jenkins or TeamCity job that is now running your night run or a sanity test or whatever, or any build, then you can see within the job itself the results of all the visual tests that took place there and actually perform all the maintenance and analysis directly from your CI system. And this leads us to the last step, updating the baseline. And for all those tools that report the images and differences on the file system, they usually include a command line interface tool that allows you to specify that you want to update the baseline for a certain test. And this tool will basically handle for you the renaming of images, copying to folders, and all of that. Other tools will take it a step further, give you some UI, like in this case Gemini, which is an awesome tool that allows you to, see the differences, see the baseline image, the current image, the diff image, and click a button to replace the baseline image with the current image, which is awesome. Now, when you're looking at the different tools, also ask yourself if you need to have different baselines for different branches of code. Just like you have, if you're working with branches, if you have feature branches or any other use for branches, and those branches contain different pieces of code, this code can produce different versions of your UI. So you'd like to have the ability to branch your baselines as well. It's important to keep your CI test green. It's important if you are maintaining multiple versions of your applications in parallel. It's important if you want to do acceptance test and run the current release candidate against the baseline of a previous release to see what's changed. And it's also very useful to retain a visual change log that shows and documents the evolution of your application, allows you to go back in time and see how everything looked like the previous release or previous quarter or previous year. Now, one of the most important practical things that has to do with visual testing is the fact that in some situations, even a single change to your application can manifest itself dozens or hundreds or even thousands of times in your test results. Now, to take an extreme example, let's assume that we have a website with many pages and we just change the header of that website. So this change is likely to appear in a huge amount of tests because the header appears in all the pages and you're testing on different browsers and different screen resolutions, and in all of them the header is apparent. So because of this, all the tools allow you to have like a depth switch that basically overrides the baseline completely, so you don't have to look at all the changes one at a time and approve them. But doing so is very risky because if you're not looking at the changes and just approving everything, you might be approving some bugs. And if you do that, they become part of the baseline, and the tool won't be able to let you know when they are there because he will start expecting them as if they are the valid state of your application. What you would really like to do is be able to just see a single occurrence of each change, no matter how many times it appears in your test. And this is part of a set of features that are called automated maintenance that are unique to Applitools eyes, and I'll show you how that looks like. So in this case, we have a test suite that ran against github.com, which is a popular responsive website. And as you can see, we have many tests here. All of them failed. We can see that we are covering 2 operating systems, one desktop and one mobile. You can see that we are covering different browsers and that we are covering different viewport sizes to test the different layout modes of the application. Now, in total, we had 19 tests in various environments and viewport sizes, and we have 76 mismatches. Now, although it's easy to take a bird's eye view and see those differences and use the radar to highlight and see that they're at the header and easily approve or reject them immediately from this view, if we had thousands of these, it could be a bit overwhelming to all go over them one by one. So what we can do is ask the tool to process these changes and just show us the unique ones. And now it doesn't matter how many times they appear, we just see the root causes. So in this case, there are only 2. We can zoom in on the first set of changes. We can see that in this case, the logo, the GitHub logo changed color from black to green. Let's assume we intended to do it. We can just at the click of a button approve all these occurrences. Then we can look at the second set of changes, and we can see that here the logo disappeared, which is not what we intended to do, so we can just reject this entire set of changes and then save the entire batch, the entire set of baseline. So you can see that with just a few clicks we were able to maintain a huge amount of differences, and it's features like this and similar to it that allow you to scale up your test to run tens of thousands of tests every day without really increasing the amount of maintenance overhead that you have to invest in maintaining those baselines. And this leads us to the last part of the talk, where we described how all this fits in the modern development lifecycle. And the short answer is that it fits in every stage. When it comes to coding, then it's very useful for a front-end developer before committing code or merging it. Once he changed the UI, just to see how the change looks like on other browsers, other operating systems, making sure that there are no unintended changes in other parts of the application that it didn't think about. When it comes to unit testing, then developers can verify the components that they build that make up that and are reused throughout the applications. When it comes to integration testing, then visual testing is perfect for doing regression, UI regression test, localization test, accessibility, cross-browser and device testing, responsive design testing, and many other testing activities that without visual testing has to be done manually. The other advantage is that, as you just saw with the examples that I've shown you, it's very easy to understand the visual test reports because they just show you screenshots of the application. It's not code, it's not log files that you have to understand. Everyone in the team that is familiar with the application can understand those test reports and can do the baseline maintenance. And because of that, this set of screenshots, this dashboard also becomes a very powerful collaboration tool. And in fact, with Applitools eyes, you can even open bugs directly from the test report, and those bug indicators remain on your test results in subsequent test runs, so they are no longer hidden in your bug tracker, and they're always visible for as long as the bugs are open. When it comes to acceptance testing, then it's very, very common to validate screenshots from your staging or release candidate against the baseline of your last release, just to make sure that there are no unexpected differences that are not covered in the requirements for that release. And lastly, it's very common to do visual testing in production for many reasons. To make sure that there are no missing resources on your production environment, to make sure that there is no UI corruption due to third-party data that's gone bad or missing, or due to third-party upgrades, or even make sure that hackers didn't break into your site and change something or defaced it in some way. So with this, I conclude the presentation part of the webinar, and I'll be happy to get your questions at this point.
Okay, we have quite a few of them. I don't believe that we will get to everyone, but as I said at the beginning, if we don't get to your question during this Q&A session, we will email you an answer. I also wanted to direct you to the chat box. I put a link there to our free 45-minute visual testing masterclass. You can register there to any available date. Now we'll start with the questions. So Adam, we got a few questions about how do you set the baseline, people that missed that part in the Hello World example. So if you could do that again. Thank you.
Definitely. So the first time you run a test, there is no baseline for it. So on that first run, the screenshots are automatically set as a baseline, and starting from the second run onwards, you always have a baseline to compare against. Now, as I shown in the demo, you have several views that allow you to approve or reject the screenshot. So you can just do it from a bird's eye view. You can drill down and zoom in, and then simply approve or reject the current image. Now, automated maintenance also helps here. So in this case, we have two checkpoints, one with the thumbs up, one without. And I can choose to just approve this screenshot or approve all similar screenshots, right? And when that happens, you can see that it was approved in both steps because it's the same difference. In both of them, in the baseline, there's the same number. In the current image, there's the same number, regardless of the fact that here we have a thumbs up and here we don't have it. And so I just approved it wherever the change was the same. Now, this was enough to approve. If I click the save button, the baseline would be updated. So this is the process, okay? Or you can do it in the dashboard by grouping the differences together and then approving it once. It's just different ways of doing the same things. That's it, Adi.
No problem. Yeah. I just took myself off mute. Another question about baselines. For websites composed of hundreds of pages, how would you drive the application under test and take the screenshots?
Okay, so you can do whatever you want. I mean, you can decide. We have SDKs for practically every major programming language and every major automation framework, and we even have SDKs that work with plain images. So whatever way you want to browse the application and the test and get those screenshots for validation, you can do it. You can use Selenium if you have forms to fill. If it's just static pages, perhaps you can just have something that goes URL by URL with a configuration file and gets a screenshot and then sends it to validation. There are plenty of ways. Now, most of the visual test automation tools that are out there, they are bound to a certain way of navigating those pages. Applitools Eyes actually provides you with SDKs that you can plug into whatever it is that you want to use, whatever it is that you have existing can be, we can add visual validation to it. So it's unique in that sense. But you can do it any way you want as long as you can get screenshot, basically.
Okay, next question. We know that Selenium has different types of assertions. How does eyes check window serve as an assertion?
Okay, so what eyes check window is doing is that basically it grabs a screenshot, a full page screenshot. It deals with getting that full page screenshot on browser when it's not supported. It deals with scaling the image, compensating for zooming differences with retina screens by the operating system itself. It even waits for the page to stabilize for you, so you don't need to have any explicit weights or implicit weights or whatever. It deals with that for you, and it just sends the image for validation. Now, by default, if there's a difference, this line specifically won't fail and won't throw an exception. This will only happen on eyes closed, because when it comes to visual testing and the maintenance process, when the test ended, even if you have differences, you already have the new screenshots for the entire test. And so you can look at the whole thing and update the whole thing. If you would fail immediately as a normal assertion, then if you have 100 steps in your test, you would have a failure on the first image. You'll have to go to the report, approve it, run it again, and then fail on the next one. Look at the report, approve that step, and then run it and fail on the next one, and so on and so forth. So the right way is to let the entire test pass, do the default behavior, and let eyes closed fail the test for you if there are visual differences, and just maintain the whole thing. Use automated maintenance to just look at every change once, etc.
How can Applitools work with Jenkins and ALM?
Excellent. So without doing anything special, just by integrating Applitools SDK into your tests, then if visual differences are detected, as I explained, eyes closed throws an exception, and the message of that exception has a link to the Applitools Eyes dashboard. Now, without any type of special integration, this exception will appear in your test reports in Jenkins or ALM as the cause for a test failure. If you will look at the exception stack trace, you'll see the message with the link with the URL, and it would be, because it's a link, it would be clickable. So if you click it, you move on to the Applitools Eyes dashboard, and you can see the differences and maintain it. Now, we also have integrations with CI systems where, as I shown before, the Applitools dashboard is actually embedded. Let me get that up on the screen again. Is actually embedded within the CI system, within the job. So you don't have the list of batches on the side, but there is a link as a result of this integration between the job and all the test runs that are related to it and only to it. And you can see those test results directly within the CI system and do the maintenance directly from there.
Can you compare different sizes images. For example, 800 by 800 image to 900 by 900 baseline, or different shapes. For example, 900 by 900 to 900 by 800.
So the question is yes, and it depends. So if you are doing strict comparison and you want to know about every typo and every slight change, then of course the tool would tell you that there is a difference because the pages are not at the same size. The matching algorithm will be smart not to show you like everything is different. It will show you that there is an extra part in the image, and for instance, if it cuts through the middle of the image, it would still perfectly compare the bottom parts and the upper parts and just show you the added part in the middle. It's smart enough to do that. Now, if this is okay and there's a dynamic part in the middle that you don't care about, you can actually indicate that in the UI by placing a splitter there on that part, and then it indicates to the tool not to fail a test if the difference is contained in that part, and this part is allowed to be of variable size. Now this relates to strict matching. When it comes to layout matching, then just like I shown you here, then of course because it deals with dynamic content, of course there's no problem comparing images with different sizes. Let me locate the test. Here you can see that these images have different width, right? And if we look at the bottom, you can see that they also have different height. Okay, this is because the devices have a different form factor. Okay, so of course you can match images of different size, and the layout algorithm is perfectly capable of dealing with situation where on one side there are 2 sentences in the paragraph and on the other one there are 10. Okay, and it will accommodate for that change and understand it that it's not a failure.
Okay, so we have time for one last question, and I think I saved the best for last, Adam.
Okay.
How do you score and compare the quality of the visual difference engines, but by what measure is Applitools eyes better than the others?
All I can tell you is this. I think that there are certain things that only Applitools can do, such as layout matching, such as automated maintenance. These are extremely complicated algorithms that we've spent years working on and refining. This is one advantage that is 0 to 100. Now, when it comes to strict matching, then this is also an algorithm that we've been refining for years and years. It's an algorithm that is working flawlessly. We have customers that are running tens of thousands of tests every day on a variety of different hardware, and they never complain on a single false positive or false negative ever. Okay, so this is the level that strict is at. I don't think that you'll get to these results with any open source tool where there is a pixel-to-pixel engine with error ratios, and you'll be able to get to results that are anywhere close to this performance. But you should try it for yourself and see if it works for you.
Okay, so unfortunately, that's all the time we have for today. Adam, I want to thank you for this in-depth presentation of the visual testing ecosystem. And of course, I want to thank everyone for taking the time to join us today, and I hope to see you at our next event. Thank you.
Thank you, everyone.